Good morning. This is Math 113 lesson for Tuesday, January the 16th. Please get your math workshop out for week 3. And I would like for you to do 1 through 19 odd at the moment. Please pause the video to do 1 through 19 odd, and then we'll go over these. Okay, this should be a review of what we did last week. We're still practicing this. Number 1, 36 raised to 3 halves. Remember, the bottom number is the root, the top number is the power. So the square root of 36 is 6. 6 cubed is 216. Alright, the cube root of 216 is 6. 6 squared is 36. Next part says rewrite each expression using the exponent. Okay, you're taking the cube root of 27. You can rewrite that as 27 to the 1/3. This is the root, and it's understood 1 there. Here, this would be 16 to the 1/4. Now, the next part says write each expression using negative exponent. Number 9, 1 over m to the 7th. I can rewrite that as m to the negative 7. Going backwards. Okay, 1 over 2 times the 4th root of x. First, I'm going to rewrite that as 2x to the 1/4, and then rewrite as a negative exponent 1/2 x to the negative 1/4. Alright, let's look at our trig expressions. 300, that is in quadrant 4. Quadrant 4. 360 minus 300 is 60 degrees. Your order pair associated with that reference angle is this. In quadrant 4, your y is negative. You want the sign that says negative square root of 3 over 2. Okay, I'm going to utilize mixed numbers here. 3 goes into 16, 5 and 1/3. 1 time around the unit circle is 2, 4, 5, and a third. It's in quadrant 3. Quadrant 3, 1/2, comma, square root of 3 over 2. Since it's in quadrant 3, both are negative, both coordinates, and I want the tangent. That y divided by that will give me square root of 3. Number 17, utilize mixed numbers again. 4 goes in line 2 times with 1 remainder. That means I went around the unit circle 1 time, and I need a 4th. I'm in quadrant 1. Cosine is square root of 2 over 2. And the last one, number 19, 6 goes into 29 4 times, and you need 5, 6 more, so I went around it 1 time. The second time gives me 4, I need 5, 6 more. I'm in quadrant 2. Pi over 6, ordered pair, square root of 3 over 2 and 1/2. Remember, tangent is y divided by x. If I take this, divide by that, I want to end up rationalizing my denominator. Now remember, quadrant 2, your x is negative, your y is positive, so therefore this will be a negative square root of 3 over 3. How about that? If you do not have the sheet in that book, but you should, if you've been absent and do not get the sheet, just write this on a separate sheet of paper. Alright. Math 113, we're going to go, I'm going to teach graphing cosecant and secant before I do tangent and cotangent. I decided to do that this time. Cosecant and secant are very easy. It won't take us long. I want you to turn to page 11. Page 11. Alright. If you look at the parent graphs of cosecant and secant, you notice there's something going on in those graphs. There's asymptotes there. Why is there asymptotes? Well, let's think about this for a minute. Asymptotes do occur here because in the unit circle, if I was to find the cosecant of this, remember cosecant is reciprocal of sine. Sine is 0. If I was to find cosecant of of 0, that's 1 over 0. Before there'd be undefined. And when there's undefined in a graph, there's asymptotes sometimes. So there's asymptotes present there. So we're going to get down to 1 and 2, 3, and 4. So let's look at numbers 1 and number 1. Like I said, these are very, very easy. Number 1. Y equals 2 secant 2x. Y equals 2 secant 2x. You got to start off doing just like if you were to graph and sine and cosine on all these, and then before you graph the final product, that's when you make a little change. But still, just do it like you normally would graph sine and cosine. Okay, my amp is 2. Okay, now you say, okay, the period formula for sine and cosine was 2 pi over b. What is the period formula for secant and cosecant? It's the same thing. The period formula is 2 pi over b as well. So my b value is 2 here. So 2 pi divided by 2 is pi. Now, I'm stressing not to make you graph phase shift and vertical shift with this. It's just going to be amplitude and period, okay? So now I draw my graph. Remember, take your period, divide by 4, so that means I'm going to start by pi over 4. And I'm going to go up by pi over 4. That's 4 pi over 4, 5 pi over 4. 6 pi over 4 reduces to 3 pi over 2, 7 pi over 4, and then 8 pi over 4 is 2 pi. So I want 1 pi over 4, 2 pi over 4 reduces, 3 pi over 4, 4 pi over 4 reduces, 5 pi over 4, 6 pi over 4 reduces, 7 pi over 4, 8 pi over 4. Alright. Now, this is secant, is related to cosine. The amplitude is 2. Alright. So secant is the reciprocal of cosine, so it's related to cosine. Remember, cosine starts up at the amp. So I'm going to go here, and I'm just putting dots right now. Okay, now this is where you graph it different from where I would have graphed cosine. Now that you have your dots, wherever a dot touches an x-axis, like here, 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 there's where an asymptote will be at. So I'm going to draw an asymptote in here. Alright, there's your asymptotes. Wherever there's the other point, you just draw. So little parabolas up, but they're not really parabolas, but they do not cross the x-axis. Okay, so here I have a dot. I'm not going up there. I'm going to go down like this. And that is my secant graph. Alright, let's look at number 2. Y equals negative 2 cosecant x. My amp is 2. My period I do expect to see amp and period on these. My V value is 1, so 2 pi divided by 1 is 2 pi. Two pi divided by 4 is pi over 2. I mean, I'm going to start with pi over 2 and increase by that. 2 pi over 2 is pi. 3 pi over 2. 4 pi over 2 is 2 pi. 5 pi over 2. 6 pi over 2 is 3 pi. 7 pi over 2. And 8 pi over 2 is 4 pi. My amp is 2. Alright, cosecant is related to sine. So at sine, you start the origin. But watch this. Still not, you see it little negative there, some kind of reflection there. So we start origin, instead of going up here, we're going to come down here and put our dots. Just like secant, wherever it touches the x-axis, there's an asymptote. It touches here, 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 and here. So you make those asymptotes. And we come down here. It cannot cross that x-axis, so it's pointing downward. This is page 11, like I said again, page 11 in your notes. Now let's look at number 13. Y equals secant 1/2 x. My amp is 1. My period is 2 pi divided by 1/2, which is 4 pi. Take 4 pi divided by 4, that's going to be pi, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. We're graphing 2 cycles. 2 cycles. Secant is related to cosine, so it starts up here with an amp, and put a dot here, dot here. Where it crosses the x-axis will be an asymptote. And there's my graph. Number 4, y equals cosecant 4x. My amplitude is 1. My period is 2 pi divided by 4, which is pi over 2. Take pi over 2 divided by 4, it needs to be pi over 8, so I'll start with pi over 8 and go from there. 1 pi over 8. 2 pi over 8 is pi over 4. 3 pi over 8. 4 pi over 8 is pi over 2. 5 pi over 8. 6 pi over 8 is 3 pi over 4. 7 pi over 8, and then pi. Cosecant is related to sine, so you start at the origin and go up to the amplitude. Sorry about that. Let me clear that dot out. Okay? Wherever it crosses the x-axis, the dot on the x-axis will be an asymptote. So here, 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 and here. You graph two cycles. So our learning target was, I can graph, make sure you put this in the notebook, I can graph cosecant and secant functions. I can graph cosecant and secant functions. So now I want you to practice in your notebook sign at page 19, numbers 9 through 12. Page 19, numbers 9 through 12. Pause the video at this moment and do those 4 problems, and then we're going to continue on with tangent, intro to the tangent function, learning about the tangent function. So do those 4 problems now, and then continue on with the video. Alright guys, I hope those 4 problems didn't give you any trouble. Now we're going to go on, we're not going to do much with tangent, we're just going to talk about tangent and cotangent and the period and amplitude, and then we will talk more about graph and tangent, cotangent on Wednesday. Okay, so let's look at the parent function y equals tangent x. Okay? I'm going to draw this so this will be a visual for you. Okay, and we want to fill in this chart. Negative pi over 2 is here. We want the tangent. Remember, tangent is y divided by x. Well, if I take negative 1 divided by 0, that is undefined, isn't it? Undefined. Negative pi over 4 is down here. So you know the tangent is y divided by x. That would be a negative 1. Because remember the ordered pair from negative pi over 4 will be square root of 2 over 2 and negative square root of 2 over 2. 0 is here, y divided by x will give me 0. Pi over 4 is up here, tangent that's 1. Pi over 2 is here, y divided by x will be undefined. 3 pi over 4 is over here, that would be negative 1 because one coordinate is x. Oops, sorry. We have a focusing problem. Okay, now. Pi is here, 0 divided by negative 1 is 0. 5 pi over 4 is down here, that would be a negative, that would be a positive 1. Tangent 3 pi over 2, negative 1 divided by 0 is undefined. And then 7 pi over 4 will be negative 1. Then we're back at 2 pi, which is 0. Okay, so now we're going to graph this. Now, the question is, what do we do when we graph something that's undefined? Well, it's undefined. It means it's either got an asymptote or a hole there. In this case, it's an asymptote. This does not exist at that. So, we're negative pi over 2 right here. We're going to draw an asymptote. So yes, tangent and cotangent involves asymptotes at pi over 2. At 3 pi over 2. Okay, now go back here. Negative pi over 4, which is here. That's negative 1, 0, 0. And it goes something, the graph looks like this. Alright. 3 pi over 2 is here. And there's your graph of the tangent. Okay, tangent function. Alright, the period, okay, now, sine and cosine, I gave you a moment to look at that and make sure you understood that. You know, the period for sine and cosine is 2 pi. That goes with cosecant and secant as well. But for tangent and cotangent, your period is pi. Okay? The blank hole at the end of each cycle, that's asymptote. Now, on sine and cosine, the domain was all real numbers. But here, do you think the domain here is all real numbers? No, because you have asymptotes at certain pi over 2 intervals. So, but before we get to the domain, let's look at range. It does have end behavior. Sine and cosine didn't. It keeps going up, and it keeps going to positive infinity and negative. So, range is all real numbers. And the domain of these are complicated. I'm not asking you to give me the domain range on these, but the domain here, you can't only write that interval notation because you have to stop so often with parentheses, so you just write it like this. X cannot equal pi over 2 plus n pi. That takes care of every time there's an asymptote, like pi. Let n be 0, well, that would be pi over 2. Let n be 1. 1 pi plus pi over 2 equals 3 pi over 2. If you put 2 in here, 2 for n, 2 pi plus pi over 2 will take care of 5 pi over 2. So that's how we write the domain for that. Alright, let's look at cotangent. I'm going to draw a picture right here just to help you fill out the chart here. Negative pi over 2. Cotangent. Remember, cotangent is x divided by y. 0 divided by 1 is 0. Negative pi over 4 would be negative 1. Cotangent is 0. 1 divided by 0 is undefined. Pi over 4 is 1. Pi over 2, x divided by y is 0. 3 pi over 4 will be negative 1. Pi will be undefined. 1. 3 pi over 2 would be x divided by y, 0. 7 pi over 4, negative 1. And 2 pi will be undefined. Alright, let's graph this. Undefined. You notice the shape of a cotangent graph. Like tangent goes like this, cotangent goes like that. The period of cotangent is pi. Once again, the asymptotes are at the end of each cycle. Your range is all real numbers. And domain, remember the asymptotes are at pi, so interval x cannot equal pi n. That would take care of that. I want you to take a moment and look at those two before we start our last little part here. Alright, you know what? We're going to stop right there for today, and I will pick up on this on Wednesday, okay? So make sure you know how to graph secant and cosecant, and you're familiar with the direction of the direction of the function for tangent. Understand why there's asymptotes in both of these, because at those points when you say y divided by x for tangent or x divided by y for cotangent, it is undefined. So we'll pick up here at the bottom of the note taker on Wednesday. And remember, your tree quiz will be on Wednesday.